For most of human history, our world's map was defined by static, immutable barriers. Oceans and mountain ranges dictated the absolute limits of human movement. Vast, extreme distances took months to cross. Military combat relied entirely on physical mass to overwhelm an opponent. And ocean currents strictly dictated human survival and regional climates. Today, technological acceleration and environmental feedback loops are dismantling these three geographic laws simultaneously. Human activity is transforming the once static map into a fragile, dynamic system. Consider the absolute maximum geographic limit of the globe, the immense planetary distance between the United Kingdom and the east coast of Australia. They sit on nearly opposite ends of the Earth. In 1919, the friction of crossing this space was immense. The pioneering flight between London and Australia took nearly 28 days and required 23 separate stops. Decades of progress brought that travel time down. Mid-century aircraft reduced the journey to a few days, but the constraints of fuel and weight required physical layovers on the ground. That limit vanishes in 2027. Airbus engineered a solution with the A350-1000 ULR. By adding an extra 20,000-liter fuel tank and reducing the payload to 238 passengers, they closed the range gap. This aircraft will launch the world's longest commercial non-stop flight, bridging the two opposite ends of the Earth in 22 hours. Aviation engineering has effectively bypassed the greatest geographic distance on the planet. In warfare, the historic rule of attrition is simple. The military with superior physical mass, a larger geographic footprint, and more armor inevitably grinds down a smaller opponent. When defending against the Russian invasion, Ukraine faced a severe deficit in conventional artillery mass. They deployed an asymmetric technological countermeasure, the mass production of explosive FPV drones. This tactical schematic illustrates how the extreme density of these drones creates a highly lethal 30-meter-deep kill zone along the front line. This saturation acts as an impenetrable barrier, repelling mass-armored breakthroughs. Intermediate and long-range drones are then used to bypass the front line entirely. They strike targets up to 1,750 kilometers away. These strikes target oil refineries, systematically choking off the revenue and fuel required to maintain a massive military force. Cheap, decentralized drones have offset the geographic and numerical advantages of a traditional superpower. Europe's climate is truly a geographic anomaly. Despite sitting at extreme northern latitudes, the region remains warmer and more mild than its location dictates it should be. This map shows the reason for that anomaly: the Atlantic Meridional Overturning Circulation, or AMOC. It acts as a massive global ocean conveyor belt, pulling warm tropical water from the Gulf of Mexico up toward Europe. Fluid dynamics drive this system. In the extreme north, cold, high-salinity water becomes dense and sinks. As it drops to the ocean floor, it pulls the warm surface waters northward to replace it. Rising global temperatures are accelerating the melting of the Greenland ice sheet, dumping fresh water straight into the North Atlantic. This influx of fresh water dilutes the ocean's salt density. Without that high salinity, the water becomes too light to sink, stalling the AMOC conveyor belt. If the AMOC collapses, northern Europe would experience an extreme freeze, while the oceans around Antarctica would rapidly heat up. Rising temperatures are now destabilizing the vital geographic mechanics that maintain regional climates. Human innovation has eliminated the ancient barriers of physical distance and military size. But this achievement carries a steep environmental cost. The acceleration bridging the globe is now driving the destabilization of its most critical geographic systems. Humanity has spent thousands of years trying to navigate a static map. We are currently unprepared for the volatile, rapidly shifting reality we have created.